We are going to now look at comparing two samples, and we see here a difference between independent and paired. So in this example, we are saying let mu sub s and mu sub w be the average pitch speeds from the stretch and the windup. Okay, and so we have some pitches from the stretch and some from the windup, and we want to know which, we wonder if these means are significantly different. Okay, so we're asking, are the means the same or are they not? And pause me and go ahead and make this comparative box plot that compares the stretch windup category and the speed category, and you'll get something like this. And though it looks like the windup has a lot less consistency than the stretch, the means do look quite similar. So no, I do think that the means, let me take some of this stuff out, the means do look similar. So I would not reject, so do not reject the null hypothesis. Okay, let's go ahead then and run the test. The first thing we want to know, if you look at this data analysis and we come down with the t-test, we've got, do we have paired, two sample equal variances, two sample unequal? So is this data paired or not? We have data from the stretch and from the windup, but it's not like each stretch pitch corresponds to each windup pitch. If that was the case, then we would have paired data, but it's just that we have a bunch of stretch data, a bunch of windup data, and so they're independent of each other. Now, before we run the test, I want to sort this column so that it has all the stretches together in column B. So I'm going to go here and I'm going to sort. We'll sort on the stretch windup category, yes. We have headers, yes. Okay, so now I have all the stretches first. We're going to go back to the data analysis. So we have independent data. So it's either the equal or unequal variances, and always assume unequal variances unless you have a reason not to. All right, we're going to fill this stuff in. So where should the first range be? So the first thing I'm going to do is I'm going to take the speeds from the stretch. Now, I don't think I mentioned this before, but do you see here with the labels? If I included this, then I would check that labels button. But since I'm going to be picking up the wind-up stuff later and not having a label, I'm going to choose to not include the label. So I'm just going to get these stretch pitches. And then I'm going to come down here and get the wind-up pitches. Now, what is the hypothesized difference? We are asking if they are the same or not. So we're hypothesizing the difference is 0. Again, we do not have labels. Labels means we would include, like in the last one sample test, I included the header. We're not going to here. Let's put the output right. That's a fine spot. And there we go. All right, let me make it look a little pretty. So merge that, put a box around it. I like to get these specific. So these are our stretch velocities. These are our wind-up speeds. Okay, and we see that the wind-up variance is bigger. It's more spread out, which is what we said, more spread out. Okay, so the hypothesized difference is 0. what is the actual sample difference? There's the wind up. Here's the stretch. So a sample difference of about 1.57 miles per hour. Now, is that because there really is a difference, or is it just due to chance? So our test is two-tailed because there's a not equal to null alternative hypothesis. The statistic is this negative 1.86, and it's a t. So t equals, oops. Remember, 3 or negative 3 or more extreme is very unlikely. So this is not really that unlikely. What's our p-value? Our p-value, we are doing a two-tailed test. So there's our p-value, about 6.3%. I like to highlight that and stick it in here, because then I can go up and like get rid of all those a lot of decimal points. Should we reject it? Well, we reject if that p-value is less than 5%, and it's not. No. Do not reject the null hypothesis. Okay, now let's go back and fill in our p-value statement. So assuming the null hypothesis is true, which says those two means are equal. So assuming the mean pitch velocities from the stretch and wind up are equal, the probability of observing sample data, like what we saw, are more extreme. So it's the probability that this difference is 1.57 or more. So the probability, the difference in sample means is 1.57 miles per hour or more, is 6.3%. So even if there is no difference, we're going to see samples that have a difference of about 1.57 or more miles per hour, 6.3% of the time. Well, we're seeing that's quite a bit. So we are not going to reject our null hypothesis. We don't get to reject it and go with this. We have to stay here. So we conclude there is no significant difference between the mean pitch velocities from the stretch and wind up.